Thank you, Eric. Yes, indeed, we do have two fine speakers tonight. It's my pleasure to introduce both of them, Christopher Steffen and Claire Iseton. As I think most of you know, they're here to tell us about the state of the fishery on the Gulf Coast in light of the severe weather event we had a few months ago. But I'll tell you a little bit about both of them before they get started. Chris's primary field of study is the small and large scale connectivity of marine fishes with an emphasis on how it relates to wildlife management. His graduate program research involves studying the ingress and egress patterns of southern flounder in Galveston Bay, which provided information about the timing of migration events that provided an increased ability to identify critical migration pathways and spawning time periods. He's now involved in the regular monitoring of fish populations in the Galveston Bay system. Along with Christopher, we have a second speaker tonight. They'll be speaking in conjunction. Claire Iseton will also be part of the presentation. Claire is a coastal ecologist and ecosystem resources program specialist. She specializes in fish and wildlife kills and population event investigations that impact coastal waters of the upper Texas coast. She holds a master's degree in marine biology from Texas A&M University at Galveston and has a particular interest in the ecology of migratory species, including sea turtles, fish, and birds. In her free time, she enjoys fishing, crabbing, birdwatching, and playing the drums. She's well-rounded. Claire, importantly, as is the case with Chris, is a member of the Texas Parks and Wildlife Department Spills and Kills team. So they are right on the money for one of the hottest topics on the Gulf Coast. That is the state of the fishery in light of the freeze. So I'm looking forward, as I know all of you are, to their comments tonight. With that, Eric, I'm going to toss this back to you to let them get online and on the screen. Thank you.
Hey, Eric, are you able to see the screen and the presentation just fine?
Yes, we see the Texas Parks and Wildlife logo there.
Okay, perfect. I can start whenever y'all are ready.
We're ready.
All right. Well, as Jim said, I don't know that I can give a better introduction than that, but let's see. Hopefully, we're not gonna. There we go. So, as Jim said, we're going to talk a little bit about the big freeze, Winter Storm Uri, some of the historical context and aquatic life impacts. So I'm going to take the first portion of this presentation to kind of talk about, as our background might have suggested, we're very interested in coastal ecology and how how these things impact fish beyond just what may be, visible to the eye as far as, and you may see fish kills, but some of the other impacts and understanding some of the biology about it. So that's kind of what I'm going to talk about. I'm going to give a little bit of background information on the Coastal Fisheries team and the long-term monitoring program that we run. Claire super gracefully accepted the invite to help on this because she's part of the Kills and Spills team. So really there's nobody better to talk to or better equipped to talk to about this. So with that, we'll go ahead and get started. We've got some lovely pictures there illustrating how bad that freeze was. So just to provide some background information on my side of things with the Coastal Fisheries team, we're in charge of, each bay system has a different team, and we're in Galveston Bay. That's where my team is. We conduct routine monitoring throughout each bay system individually. And so this has been super important and has been going on for a really long period of time. And basically what we do is we're doing this routine sampling monthly with different gear types to try and target adult fish, juvenile fish, and understand, creating baselines for these fish populations and what might be healthy. But it also allows us to sort of estimate or see what the response is to different events throughout the year. So we conduct monthly sampling using bag stains, which are on the shoreline. We do bay trawls in the middle of the bay. We do Gulf trawls in state waters, just up to 9 miles offshore. And then we also do oyster dredges. So we're really in charge of monitoring all of the fisheries in the bay system. So it could be anything from southern flounder to the oyster population. And we also, during the spring and fall months, we do gill net sampling. And so I don't know how many people are familiar with that, but the picture on the bottom is actually us processing some samples. We use different mesh sizes to try and target different size classes of fish. And we take measurements and then release most of the fish back. And then we also do creel surveys. So if anybody in the group is from Houston, you may have already met one of us before, or me. We go to the boat ramps. We have a low use season when fishing pressure is a little bit lower. And then we have a high use season, which is typically in the end of spring and most of the summer, where we're doing one of these surveys almost every day. And so we'll go out to a boat ramp. We conduct fishery surveys where we interview fishermen and boaters to see how their trip was. We ask questions, anything from, on a scale of 0 to 10, how satisfied were you with your trip? And then we actually measure and count every single fish that they have on board. And that allows us to get an idea of what's being targeted most in different areas, which fishing ramps have the most pressure. You can see seasonality, what's being targeted. Obviously, in the fall, we see a ton of flounder come into boat ramps. Or in the spring, you might see, a ton of redfish or trout. It just allows us to, again, long-term monitoring of what's being targeted, where our needs are at in terms of conservation and sustainability. And that actually, everybody knows, I don't know how much people know about our team, but that's an oyster dredge on the right. So we actually go out and check on the oyster reefs in Galveston, extremely important part of the ecosystem as well. So with that, I'm going to transition a little bit into just the overall role of temperature in fisheries and how important it is and how big the impacts can be from some of these weather events, whether they be really hot summers or really cold winters. So water temperature is one of the most critical environmental parameters that can affect fish populations. Specifically, certain species are super susceptible to responding in a negative way to rapid changes in temperature. And so most fish species that you're going to find are going to be what we call ectothermic. And so they're relying on that ambient water temperature to thermoregulate their body temperature. And so if the water temperature of the bay or the body of water drops super quickly, then the body temperature of the fish is also going to drop really quickly. And then just a little bit of insight too, I just think this illustrates it really well. This is where I was talking about the ecology portion of it and that aspect. It goes beyond sort of what you might see on the shoreline in terms of a fish kill or how these things affect fish populations. Water temperature can be and is proven to be a driving factor that affects fish behavior and migration. So really popular example, and luckily I was fortunate enough to do some work with the A&M Galveston for my graduate research. We used acoustic telemetry to try and track the migration patterns of southern flounder to determine the actual months and the pathways that they were using. And so you can see on that plot there, I just think it illustrates the concept really well, that these things are not just, killing fish or, promoting productivity. They're actually driving fish behavior. And so you can see there on the y-axis, you actually have mean distance traveled by these southern flounder all the way up to almost 14 kilometers. And you have temperature plotted against it. And so you can see the periods of highest movement among those fish is when the temperatures drop. So this, temperature can be detrimental to fish populations, but it's also a necessary factor in helping these fish know when to migrate offshore to deeper waters. And it can be a critical parameter in driving reproduction and all kinds of things. And I'm more than happy to talk about southern flounder stuff if anybody has questions later on. And then just more information on some of this. So water temperatures outside of the normal range may result in fish mortality due to internal biological changes. So really quick water temperature change, especially dropping down, can affect a fish's metabolic rate. There's a lot of biological changes that take place within these fish that can be really harmful. And And then there's certain areas along the coast that are susceptible to higher fishing pressure during these cold weather events. So I don't know how, plugged in everybody is to each bay system and in each area, but down here in Galveston, we have like Offutt's Bayou, Moses Lake, and some of these other areas where you've got these spots where you've got deeper pockets of water. And deeper water is always going to be a little bit warmer than some shallow water along the coastline. So what happens is what you want to happen is fish, get a little bit of a environmental cue to move to some of these more stable thermal waters and refuges where they can acclimate to some warmer water at depth. And so what we do in response to that, because what happens is people know that these fish stack up in these deep holes when it gets cold. So you'll get fishermen going out and trying to target these fish. We saw it happen with this last one. And so that's why we have the power to issue these fishing closures to certain regions so that we can try to protect these fish that are really just trying to acclimate and prepare biologically for the colder temperatures that are coming. And these locations with the deeper water, like I said, are basically these thermal refuges. It's no different than turning the heat on in your home and trying to hunker down inside like we all did. So here I'll talk a little bit about how these changes actually occur in fish. So rapid decreases in temperature are particularly stressful for fish. What that does is it reduces the time frame that these fish have to find these deeper thermal refuges and acclimate to a little bit warmer water or try to find some refuge in those areas. And so like with this last one, we had a severe temperature drop really quickly. And so those quick and sudden changes make it really difficult for these fish to, if they're in Trinity Bay in a shallow area, that shallow area is going to get a lot colder a lot quicker than some of these deeper areas. And so when it's really rapid like that and it's rapidly decreasing, it's really difficult for some of these fish to make it down there. The stress caused by extreme cold temperature can have lasting effects on these fish populations. And this is something that's really important to think about. TPWD does a lot in preparation for these events. I know our team was scrambling to try to get everything done and try to do what we can to protect these populations. But there's lasting effects afterwards where even if these fish survive, they're so stressed internally that they can be more susceptible to disease, parasites. And so there are lasting effects long term, even if a fish, appears to be healthy after surviving a cold weather event. And then this plot actually shows the critical temperature minimums of 3 different size classes of spotted sea trout. So spotted sea trout, everybody knows, do not do well in some of these really rapidly decreasing colder water events. And so here you've got juvenile size fish, young adult size fish, and then adult size fish. And so if you look there, basically 35 degrees and 37 degrees Fahrenheit, you've got these mortality events happening. And Claire's got a really good figure that she's going to show that kind of illustrates where the temperatures were during this last event and how those might have affected these fish. But you can see that they're really sensitive to some of these colder water events that we saw. So as far as minimizing impacts, what we do on our side, it was a very busy time for us trying to get prepared for this, but we, like I said, implemented these closures on deeper, more thermally stable environments 48 hours in advance. It's pretty crazy. What happened was, even 72 hours in advance, when the temperature started dropping a little bit, these fish will respond to that and start moving to these more thermally stable environments. And so it's critical that we get out there and close these areas down to fishing, because we had boats stacked up in Offutt's Bayou where it's a little bit deeper and they've got some deeper pockets of warmer water. And fishing pressure, is the last thing that a fish population that's struggling to acclimate at the time needs in that moment. And then we do have the power to shut down completely throughout the period of fluctuating temperature. Our team conducts rapid fish kill assessments. And so Claire's going to talk about sort of the kills and spills team side of things with fish kill assessments. But we're on the water constantly, at least our team is, conducting those regular monitoring program gear types and sampling types. And so when while we were out the next day or 2 days after, while we were out, if we see something, we check for density of dead fish. If we encounter dead fish on a shoreline, we do some rapid fish kill assessments until a more formal assessment can be made by the kills and spills team. And then the other important thing too, why I brought up the long-term monitoring program, is the monitoring program really maintains and created a baseline for some of these fish populations. So since we have this expansive data set over 40 years, we're able to see trends in populations among different fisheries, especially specifically for each different kind of species that we see. And what that does is, if we have data from the last 10 years, we can compare that data to the data that we're going to see this year in terms of how maybe some of these fisheries were impacted by this cold weather event. And one thing to note on that too, I told Jim this, but what Claire has is going to be the bulk of the data that TPWD is issued. And if anybody's interested, what we're providing is sort of a snapshot today, but there is actually a winter storm report available on our website. And so if anybody really wants to get into some of the mechanics of everything and the deeper data dive, you can look that up. It's available for the public. But our spring gillnet data, we're just now collecting that in the last 2 weeks. So our gillnet season just started. And that's going to last a little while. So we don't have anything on our side necessarily in terms of data to present that's extremely recent to this event. And then one thing to note too, Claire and I talked about this a lot, is sort of the effort by each individual Parks and Wildlife team. And we've got Coastal Fisheries offices up and down the coast. But there's only so many of us, and there are a lot more recreational fishermen out there or commercial fishermen. And so one of the things that we were talking about is how important public fish kill, public reporting of these fish kill events is to us, because we're not able to cover every square acre of the water, obviously. And so when the public is out there fishing, whether it be 2 days after or just before or during an event, it's really important to get accurate reporting from the public on this so that we can go out and make accurate assessments and do our best due diligence to really encompass all of the effects and impacts from these types of events. One thing I'll note too, you'll see later on, this is sort of what I was talking about with the ecological side of things and those deeper thermal refuges. You'll see that the upper coast was not hit as hard as the lower coast. Claire and I talked about that a lot in depth, and there's a lot of different reasons that could be, but one of the reasons that we talked about is we actually got a smaller cold front in January. And so when I was talking about water temperature being an environmental cue, that environmental cue in January, even though it wasn't as severe, may have been enough to drive some of these fish into these deeper waters where they're already acclimated and more thermally stable, to where they were put in a better position to survive an event a month later. So just keep that in mind. I guess the main overall thing of my portion of this is people tend to focus on the pictures and things like that. There's a lot more ecological impacts to this and long-lasting effects on fish populations. It can change their behavior. It can keep fish offshore by not, cueing them to migrate back into the bay system with warmer waters if we get a delayed cold event. There's just a lot of possibilities for these kind of events to affect fisheries populations. And so just keep that in mind. But I think now I've got Claire on this next part. And so Claire,
So Chris, there's a couple of questions in the chat room.
Absolutely, yeah. Let me see if I can.
So the first question was, which species was the most affected by the freeze and in what area? I think you mentioned it already.
This will be more in the second portion of the presentation, but okay. It's going to be spotted sea trout was really affected, but Claire's going to have to probably talk about that more. She's got all the numbers down way better than I do on that stuff. The Kills and Spills team has a bunch of data put together really well.
Okay.
There's Claire now.
Hey everyone, let me get this pulled up properly, making sure that we got the full screen function up. Can everybody see everything, or am I in a presenter mode right now?
Yes, you're presenting.
I think you're good, Claire.
Yes,
Perfect.
it's good.
Yep, you're
Okay, good deal. Thank you, Chris, for that setup, because you know, as you mentioned, temperature is really a major driver for fish movements, you know, throughout the year under normal circumstances, and of course, this is certainly an exception to the rule in the case of February. And for our particular group, the Kills and Spills team, we go out and we investigate fish and wildlife impacts from both human and natural stressors. So in the case of this winter fish kill, that kind of comes right into our wheelhouse. And in order for us to be able to effectively collect the data that we need, you know, time is of the essence, and in many cases we end up with data that really is an underestimation of the total impact, and that's where Chris's group comes in, because we have this 40+ year data set that looks at various life history stages and size classes of our commercially and recreationally important fish species, to be able to gauge how these small pulse events kind of have these longer term impacts over time to our populations. So that's kind of what we do. And I know there was a question about the photos. Most of these were taken down on the lower Texas coast. So the upper and lower Laguna Madre was where we saw the greatest impacts as a result of this winter fish kill. And we'll go into the nitty gritty of the actual numbers here in a little bit. Let's see here. So for the water temperatures, this graphic does a pretty good job of illustrating what was happening kind of mid-February, where between the 11th to the 15th, we saw this very, very sharp drop in water temperatures, kind of leading into its peak on February 15th and 16th. And so this is still a relatively gradual drop, but this wasn't overnight. This did happen over a period of a few days. But what's interesting to note here is, you know, we have spotted sea trout and red drum, both of those temperature thresholds. Those temperatures dropped right into where we would anticipate to see mortality of those species. And what's even more illustrative is that these temperatures actually reflect the temperatures at the passes. So when we talk about water temperatures inshore in our back bays, where it's much, much shallower, there's less thermal inertia, there's less water, so it gets colder even faster than those temperatures that we're seeing here at the passes. And so the result of that was this large scale mortality event, particularly down on the lower Texas coast. And as Chris mentioned, in mid-January, we did have a small cold front event that was not experienced and not observed on the lower Texas coast, that also kind of factored into what we saw in terms of our data observations for the upper Texas coast. So we actually got started in our response activities about 2 weeks out before the arrival of the worst of the cold front event. And so, as Chris mentioned, we had a couple of tools in the toolbox that we utilized to kind of minimize adverse impacts to these fish on top of the already existing, you know, impacts from those temperature drops. So we have 21 thermal refuges up and down the coast. And what we sought out to do immediately was to initiate a temporary closure, 48-hour closure during the worst of that temperature event. So that was the 15th and the 16th. And then in addition to that, on the lower Texas coast, different from what we experience up here, there's less deeper pockets of water, particularly down in the upper and lower Laguna Madre. And so the intercoastal waterway has been thought to be a little bit of a thermal refuge for those fish species, which kind of creates this interaction, this potential interaction with our barge operators that use that intercoastal waterway year round. So what we also look at doing is initiating voluntary suspension of barge and towing operations. And thankfully, we have a great partnership right now with the Gulf Intercoastal Canal Association, and also a partnership with Texas A&M Corpus Christi, where we have some modeling predictions that gave us a very early indication of a significant cold weather event. And so on top of that, we have impacts to other species. And so sea turtles was something that we were also concurrently looking at and trying to recover from the waterways ahead of the worst of the cold weather drops. And sea turtles have a much, they're way less tolerant to these cold weather temperature drops in the water. And so that's somewhere between 46 degrees to 50 degrees compared to our speckled trout at 39 degrees Fahrenheit and our red drum that are a little bit more tolerant than our speckled trout. So they're kind of thought to be the canaries in the coal mine, so to speak, and a great indicator of what is to come in terms of a potential fish kill assessment. So we were really kind of doing side-by-side operations and the recovery of those sea turtles in addition to planning for our fish kill assessments post-freeze. So we started to get reports as soon as February 14th and February 15th. So we were, as soon as we could, it's an all hands on deck situation. So just about every single member from our entire division coastwide was out and about and conducting various assessments just to look at the total extent of fish kills. So what Chris mentioned before is that we really start out a little more broadly by looking at, by performing rapid assessments and then utilizing some of the already existing sample methodologies that we normally use to kind of get a peek at what's happening. So these relative densities of, let's say, like 100 fish per 1 foot versus 10 fish per 1 foot. Those are giving us a relative gauge of the level of impacts by base system. And so those rapid assessments are also informing certain areas where we can target for more formalized assessments. And so what we use is a protocol that was established years ago by the American Fishery Society. And so if we have an entire linear extent, let's say it's 1,000 feet long, our goal in those formal assessments is to count every single fish, regardless of species, size, and all of that. We collect all of that information for a minimum of 10% of that 1,000 foot swath. So these formal assessments were, again, done all up and down the coast to give us more specific information about what was happening per base system. On top of that, we were also, again, looking for information from members of the public. So most of the time it's folks like you that are out there going out fishing, seeing these fish on the ground or on the shoreline that are informing some of these areas for formal assessments on our end. So just as much effort as we put in is also dependent on some of this public support and this community engagement aspect when we have these kinds of events. So some of the other newer technology that we're looking at too is using drone overflights. So this is one of the first winter kill events where we were able to use drones to be able to assess certain fish kills, because as a result of these fronts, water gets blown out pretty badly. So normal skiff use to get out to these spots is really, really challenging. So that's where these drones can really come in and be helpful. And we've also gotten information from the public who are doing regular overflights in Cessna planes or helicopters. So all of this information was really, really critical in helping guide our formal assessments. And here, with that, here's sort of the numbers and really kind of, the crux of I think what everybody's asking is what is the extent of the impact? And so based on our initial assessments, which were carried out for several weeks from about, February 15th on, we had a minimum mortality estimate of 3.8 million. Again, that's a minimum estimate because it's for all of these fish kill response, there's really not an ability to enumerate every single fish that's been impacted from these winter events. Some of them float and some of them sink, and that's the product of decomposition rates. And there's also predation by other species. This provides a source of nutrients and food sources for some of our predator species. So in the case of this particular event, 91% of what we saw of that 3.8 million were non-game fish, the bulk of which we saw were silver perch, which is kind of related in the same general family as our red drum species. And then other species that we saw in high abundance were hardhead catfish, pinfish, anchovies, and striped mullet. So for anybody that lives or is rented in any kind of canal subdivision houses, If you happen to see fish in those particular canal subdivisions, striped mullet were the bulk species that we observed post this winter kill event. So of that 3.8 million, only 9% of what we observed were actually game fish, with the greatest contributor of that 9% being speckled trout. And that's really what I'm going to talk about for the most part in the subsequent slides here. And so this also breaks it down by general bay region. As Chris mentioned, we have multiple ecosystem teams that are spread up and down the coast. And so they were instrumental in gathering some of the data that we were using to kind of generate these graphics. So as you can see, really on the bottom of the screen is the most telling part, is that the upper and lower Laguna Madre experienced the greatest impacts as a result of this freeze event. And then it tapers off as we go further north up the coast. And then to break it down a little bit further here, this is kind of, again, looking at that 9%, that those game fish species that we're all very concerned about. So coast-wide, that pie chart is kind of on the bottom right-hand corner, and again displays that speckled trout was the most impacted species. And again, that speaks to that thermal threshold of I think it's 42 degrees Fahrenheit for speckled trout and 39 for red drum. And then there's all those species broken down by region. So interestingly enough too, there's been a little bit of a change in distribution of the game fish species that we see coastally as you go up and down the coast. But again, speckled trout is really kind of the most representative of that 9% that we see. So to put this into a little bit of context, this has really been the most significant freeze event that we've had in the past kind of 20 years. The bigger events that we really observed were in the early to late 80s, with the 1983 freeze event in December being one of the biggest mortality events that we saw, where 14.4 million fish were impacted. And so just based on the growth rates of speckled trout, what we see through that resources management data that Chris spoke to is that these fish tend to recover on the order of about 2 to 3 years following a major freeze event. And then to break it down into a more recent history, the 2021 event is, again, the biggest event that we've seen since 1997. In 1997 certainly was pretty large too by comparison. And so with all of these, we're utilizing some of the same tools that I mentioned a little bit earlier about these temporary barge suspensions and then thermal refuge closures throughout certain years. But one thing that's a little bit different this year is that we were actually able to kind of compile all this information and then issue an emergency rule as a way of giving certain species a little bit of a boost to recover. So in general, these freeze events, they are naturally occurring, and we tend to see them between every 3 to 6 years, with some of the more major freeze events occurring every 10 to 12 years. So to speak to the speckled trout, because that's certainly the species that I think is of most interest to a lot of members of the public. This kind of breaks things down in terms of the impacts between the 4 major freeze events that we've had since 1980. And in the case of this particular event, our impacts were mostly observed on the upper and lower Laguna Madre, but in those prior events, there was a little bit more of a distribution that was more mid-coast as a result of all this. So these fish have moved, and there's been changes in our size structure and stock structure by location over the past few years, or past few decades. And so this also speaks to that regular data that we normally collect. So that this is, our gill nets are targeting our subadult and our adult finfish. These are the species or the size classes that we were targeting as recreational anglers. And so this kind of looks at those catch rates per hour broken down over the years. And so if the one of the measures that I see here that's most noticeable is if you look at the 1983 marker, there is that sharp drop in our catch rates of speckled trout in response to these winter freeze events. But those numbers do tend to recover relatively quickly. Again, on the order of about 2 to 3 years, we start to see that gradual improvement and return of those catch rates back to pre-freeze levels. So once all is said and done, post a fish kill assessment from a winter freeze event, we're looking at overall management considerations. Do we need to reduce bag limits? Do we need to employ various things to give these fish species a leg up? And this is again where the public really comes in and can help by certain catch and release practices. That is a great way of reducing fishing pressure and allowing these fish stocks to recover a little bit more quickly as a result. And so what we were weighing in the case of an emergency rule was looking at spawning stock biomass and how can we modulate our existing regulatory frameworks to kind of give that particular species of interest a boost in that population recovery. And so what we're looking at when we talk about those things is our size slot limit and then our bag limit for that particular species. And so again, speckled trout was the particular species that we were looking at when we were issuing management decisions. So before the event hit, we currently have a bag limit of 5 fish with that size limit of 15 to 25 inches, and then 1 fish that's greater than 25 inches. And so when we ran various modeling scenarios to kind of give that spawning stock biomass a little bit of a boost and give speckled trout that boost that it needs to recover a little more quickly, we honed in on an emergency rule that considers a bag limit of 3 fish per day with a size limit of 17 to 23 inches. And this is a temporary rule. So this is not a permanent regulatory change, but this is meant to kind of, again, give this particular species a boost and also give us a chance to see what these gillnet data inform and tell us as a result of our regular sampling. So both of those things are kind of working concurrently with one another for us to be able to make a decision after the first 120 days of this regulatory change, this temporary regulatory change, to decide whether or not we need to make an extension. So in addition to the immediate fish impacts, sometimes these winter fish kill events actually do good things for our bay systems. So one thing that we observed, particularly even as early as that January event, is that there was a reduction of aquatic invasive species. So in the greater Houston Metroplex, we have a lot of invasive tilapia. So that's blue tilapia, Mozambique tilapia, and the hybrid counterparts. Most of those were kind of wiped out as a result of that January cold weather event that we had, and we saw a similar set of impacts again when Winter Storm Uri hit. And there's kind of this unexpected boost of nutrient input as a result of all these dead fish, particularly down in the lower coast, because in the lower Laguna Madre ecosystem area, in general, it's been thought to be nutrient deficient. There's lots of salt flats. There's less carbon input in certain parts of this particular system. And so these decaying fish help provide and input some new nutrients back into that system. And so what biologists who were here back in the 80s observed is that there was a very large boost in productivity from every single trophic level that also helped improve and bolster the recovery of our fish species as a result of decay from that event. It sort of cleans the slate a little bit. One thing that we're kind of a little concerned about too is that with that influx of nutrients, sometimes we have things like red tides and eutrophic events that can occur because there's just such a flurry of activity that there's not enough oxygen in the water for all of those fish to thrive. And so that can potentially result in harmful algal blooms that can lead to fish kill events later on in the seasons. And so we're still pretty slow for these water temperatures to warm up. Chris was mentioning to me earlier today that they're still weighing whether or not they should be wearing, hip waders versus regular booties at this particular time of year, and it's pretty unusual to have water temperatures be as cool as they are this kind of late into the spring. So it's still pretty early to tell whether or not we'll observe any eutrophic events or harmful algal blooms. But again, that's where the public comes in. So if you do see these additional fish kills, this is information that we want to know about so that we can go out and continue to do assessments, because that's one part of the additional picture. So for future plans, we're still continuing to collect all that management sampling data. So gill nets are ongoing. Those are going to be going on for an additional few weeks, and we'll get some more information that'll help guide this emergency rule. And then bag seines are going to speak to our younger versions of these game fish species. Same thing with our trawls. And then when we're out there doing creel surveys, all of that information is helping give us a more complete picture of the impacts of this particular event. And so we will also continue to weigh all of this information against what we've seen and observed in the past. And because our methodologies have really been consistent over time, even in the case of formal assessments, they're more or less the same. They haven't changed too much. Some of the tools, some of the statistical tools that we use are a little more robust. They can do a lot more for us now, this day and age, than they did 20, 30 years ago. So we are able to get get this information at our fingertips a little more quickly as a result. And we're continuing to evaluate the tools that we currently have, whether we need to expand the number of thermal closures or reduce those numbers based on what we're observing. All of this data that we're collecting is helping inform some of that. And the citizen science and community engagement part is something where I hope maybe we can talk about this too after our presentation. Is we have normal reporting mechanisms to report fish kills, but for these particular kinds of events, we really do rely on the public letting us know where they're seeing these fish or not seeing these fish. And so one tool that has been implemented, at least inland, for some of our terrestrial species like birds and things like that, is we're using iNaturalist to report some of these mortalities. And so that's one thing that we're considering here in this case, and I'd certainly love to hear some feedback from y'all or any ideas that you have to be able to get the word out to help get some of this information to us, because we really do rely on your help as well. And we're considering the expansion of drone use in future surveys. And so we've also used drones recently for some other fish kill impacts that we've had since Winter Storm Uri that were not natural. The other side of this is that we have an enhancement program, and we do a lot of stock enhancement efforts at our hatcheries. And so folks over at Sea Center, Texas, and the Marine Development Center down in the Lower Coast, they're working overtime to kind of increase the spotted sea trout hatchery production in response to these events. And so those are some of the other things that we're working on here in the background always, but it's with a little more pep in our step after this winter storm. And that's all I have, y'all. Thank you so much for inviting us to talk, and happy to answer any questions that you have, Chris and I both.